Hi, this is Mrs. Slater, and there are certain formulas to know when it comes to variation: direct, inverse, and joint. You will see that the quadratics are going to be showing up, like for example, in direct variation, y equals k x squared, where k is the constant in each one of these. Inverse variation is division, where k is over x squared. And then joint variation, you're going to see y equals k times x times z. And in each case, k cannot equal 0. Okay, so what I mean by these is, for this first example, y varies directly, so there's your hint to use y equals k x squared as the square of x, so that's why there's a square there. And if y equals 80, and x equals 4, we'll be able to find the constant of variation. So you would simplify 80 equals 16k, and then k is going to equal 5. And that's all I'm looking for. Actually, no, I'm not. I'm looking for the equation of variation. So y equals 5x squared. You want to plug the constant back into the original equation. All right. The next one being inverse. Y varies inversely as the square of x. That's going to be y equals k over x squared. Use your formulas from the previous slide. Plugging in 5, you get 5 equals k over 3 squared. So then k is going to equal 9 times 5, which is 45. So then your equation would look like this: y equals 45 over x squared. Okay, the next one, it says jointly, and it says z varies. So I'm going to start with z this time as, and there's got to put the k for that constant of variation, as x and y. So it looks a little different from what I wrote as the formula, but the idea is still the same. Just look at what your variable is that they start with. Once it says varies jointly, that's where the k is going to come in. Okay, so then if z equals 42, x equals 2, and y equals 7, we'll be able to plug all those in and get 42 k times 14. And if I divide both sides by 14, I get a value of 3. Okay, and with that, I'm going to write an equation of variation, which means to replace k with the 3 and leave all the variables as they are. Okay, the next one is a little mix, so you just got to be really careful on how you're reading it. It says z varies directly as x, so that's the first part, and inversely as y. So that just means there's something to multiply and something to divide. And then they give you all the values in the next part of this problem. So you have 1 equals k times 4 all over 4, which is nice because now those just cancel out, leaving you with k equaling 1. So the equation of variation is going to be z equals 1, and we really don't have to write that since 1 can be invisible in some cases. Okay, and then the next one, w varies jointly as x and y. So let's write that down first. And then it says, and inversely as the square of z. So that just means that there's going to be z squared in the bottom. So now let's plug all the information in. 9 equals k times 3 times 6 all over 2 squared. And simplify. So 9 equals k times 18 all over 4. And if I multiply both sides by 4, I end up with 36 equals, those cancel now, 18 times k, and k is going to equal 2. Okay, so an equation of variation would be w equals 2xy over z squared for the final answer. Okay, and then last but not least is the more fun. I love it when you can make a prediction at the end to find out, or after doing all the work. So let's use the variables given. F varies inversely, so it's going to be division, as the square of the distance. Okay, use the variables given. That's going to help when you start plugging things in. The gravitational force between two objects is 50 dynes when they are 2 centimeters apart. So we are going to plug in 50 equals k over 2 squared. And you end up with k equaling 200. Okay? Then the equation of variation would be f equals 200 over r squared. So that takes everything up to that point right here. Now let's go on to the next part where we're making a prediction. Find the force of attractions when they are 10 centimeters apart. We know that r stands for the distance, so we're just going to plug 10 in for r. 200 over 100, and you end up with 2, and in this case, 2 dynes, because that is the label for that one. Okay, that concludes 8.7.